Good morning, Cardinals. This is Mr. Ernst, and today we're going to be talking about something called piecewise functions. So, let me tell you a story, Cardinals. This is the story of a cyclist. This cyclist, he starts off from home, and he leaves, and he's going a relative speed, okay? So time and distance, a little bit of time passes, and he goes a little bit of distance. So let's say he goes right about here. He travels this far, and he's having a good time. I'm actually going to change the color of this real quick. He's going this far. He's having a good time, and goes about this far. And we'll say that as he's pedaling along, he is going about 10 miles an hour. I think that's the average for most cyclists. He's going about 10 miles an hour. Cool? Notice we have change going on here. However, right at this point here, let's say at the 5-mile mark, so he's cruising along, he goes for about a half hour, tragedy strikes at the 5-mile mark. As he's cycling, he suddenly, unfortunately, suffers a flat tire. Unfortunately for our cyclist, time continues to move. So we are still going to have time during this, however, he's not going anywhere. He cannot continue to gain distance anymore, so there's no up to this line. It is just womp, perfectly flat. He is staying at 5 miles an hour. I'm going to move this up just a little bit so it looks a little bit more lined up. There we go. So at 5-mile marker, he gets a flat tire, and he's having a sad boy hours for a little bit. As he's sitting there and contemplating his life and wondering what he did wrong, he does manage. We will say that this f of x is equal to, well, it's 5. Right here it's 5, right here it's 5, right here is 5. No matter how much time changes, the answer is always still going to be 5. So he's stuck at the 5-mile marker right now as he's trying to repair his tire. However, triumphantly, he finally does manage to fix his tire. And now he's going double fast, double the speed. Double the flavor. He's going incredibly fast now. Look at him go. He's going super fast. He's amazing. So as he's doubling his speed, he's trying to get home as fast as he can. He can barely even stay on his seat. Now we have f of x is equal to, not 10x, he's doubling his speed to 20 miles an hour. Holy cow, maybe a land record. Maybe. And this is the story of our little bicyclist here. This is a function that is broken up into different pieces, different parts of the story. Where he starts, where he gets the flat tire, and where he doubles his speed, now super motivated to get back home on time. Traveling lots of distance in a very short amount of time. So, this is broken into pieces, which is why this is called a piecewise function. A piecewise function is actually kind of like several functions that are kind of Frankensteined together, stitched together to make one big function. And it tells a little story, kind of like how this one did. You'll notice that we have different functions that are happening. We have one linear equation down here. We have one static equation right here where there is no change. And then we go back to having a linear equation here as well. In fact, I could go back and change the story and say that he starts off, let's say because he was sitting there, he doesn't quite have the same energy as he had beforehand, but then as he starts to cycle, he's going faster and faster and faster. Maybe he even hits a hill. So this is starting to curve now. So instead of a linear equation, maybe this is part of an exponential equation. We'll say maybe, 2x squared. So now this is an exponential equation, so it goes linear to static to an exponential equation. A piecewise function is simply a function that is made up of different functions over time. One of the ways that we kind of talk about this f of x here, this f of x here, and this f of x here, honestly, actually, you know what? I did you guys a silly. Each one of these should be labeled as a different function because they are different functions. So instead of this being f of x, I'm going to relabel this as g of x. And then I'm going to relabel this one instead of f of x. This one's going to be my h of x because that guy is definitely a hero. H is for hero. So slow, stopped, super fast. Piecewise function is a combination of different functions. And the way that we kind of illustrate from where each function goes is by using greater than or less than. In your assignment today, you're going to be looking at, not the story of the bicyclist, but you're going to be looking at water filling up a T-shaped object. As the water fills it up, it's going to start off filling up really, really fast because it's a small amount of area, but then it's going to start filling up a lot slower because there's a lot more area for it to go. And you guys are going to be looking at what that kind of looks like. When you're looking at this, let's say that this happened, I don't know, let's say that this was at 1 hour and this one was just at 2 hours. We'll make it nice and simple. We're going to say that this function happens when x is greater than 0, because of course he had to start at 0. X is greater than 0, but less than 1. In fact, let me put this in the proper color for you too. Make sure everything's nice in color. X is between 0 and 1. We use g of x when x is between 1 and 2. So for 1 hour while he's trying to fix his bike. Oh my gosh, I got the colors wrong again. Colors are very important to me, you guys. 1, 2, the math is whatever, but like colors, that is what's very important to me. So when x is between 1 and 2, we use g of x. And then finally, the heroic victory at the end, when x is greater than 2. Would be this function at the very end here. Into infinity, essentially when he stopped. So if he did stop, let's say he stopped at 3 hours, we can say x is between 2 and 3. And just to kind of properly illustrate that, say the line stops there, and I know this isn't completely accurate because it's a little bit distributed, but let's say that's 3. So x is between 2 and 3, we use this function. If x is between 1 and 2, we use this function. And if x is between 0 and 1, we use this function. Okay? That's a little bit, I think, more than what the assignment today really asks you to do, but, you know, kind of good to know. So let's take a look at part of the assignment today. Put away the bicyclist, put away everything. Boop, and take out one of the questions in here that I wanted to talk to you guys about. So this one is giving those kind of parameters that I gave you beforehand. Essentially, x is positive, it's a positive x, if x is greater than or equal to 0. That's kind of a duh or bruh moment. It's, yeah, no kidding. If x is greater than or equal to 0, it's going to be positive. And if x is negative, it is beneath 0. Yeah, this is just, this is whatever. Over here, we're looking at absolute value of x. Absolute value of x, we're just looking at what its distance to 0 is. Or in other words, we kind of knock off, if there's any negative, we kind of just knock the negative off. So 2.5, this makes it look a lot more complicated than it needs to be, but it's really not. If you're at 0 and you're at negative 2.5, the distance from here to here, remember distance is always going to be positive. You can't measure something to have negative 5 meters. 2.5. Distance to 0, positive 2. 1.5's distance to 0 is still 1.5, okay? Remember, distance cannot be negative. I've never gone from Las Vegas to San Diego and traveled negative 320 miles, right? I don't know why I'm getting so many emails. Anyways, you're only filling this table out so you can fill in the graph afterwards. In fact, a couple of the questions you have today involves graphing. So if you do get to those ones, or when you get to those ones, if you do need extra help, please, as always, feel free to throw those equations into Desmos and see what you can get, okay? Again, this is all about absolute value, so if you don't know how to do absolute value in Desmos, I would just search it up online. Cool? I could show you, but honestly, the world of online, I want you guys, you should be able to do a little bit of research. So anyways, again, if you guys have any questions about piecewise functions, remember piecewise is just multiple functions stitched together like that. Or it could look like this, boo. Or it could look like whoop, bop, and then boo. It could look like this, where you have 1, 2, 3 different functions. If you guys have any questions, please reach out to let me know. Or please see me during the office hours on Monday, Wednesday, and Friday. Bye, Cardinals.